In Module 9, we have discussed on how we can use the sample means to make a hypothesis about the population mean. We have also covered on how we may compare the means of two populations with the use of the means of the two samples each taken from each of the populations. So in this particular module, we have a question on whether we can still use the same hypothesis testing in comparing the means of three populations. So in this particular table, we have here data from samples on the amount of nighttime sleeping hours of first year, second year, and third year college students in biology in XU. So we can see here three separate sample means. And again, the question is, can we compare these three sample means in the same way as we have compared the two means of two populations using the t-test? Do we use the t-test? Can we still use the t-test here? Okay, so remember in Microsoft Excel, when we use the t-test, the limit is for two samples. So because we are comparing here three samples from three populations, then we are going to do hypothesis testing by pair. Okay, so first let us do a t-test between the first year and the second year's amount of nighttime sleeping hours. Okay, so we can have a null hypothesis of the population mean for the sleeping hours for the first years is equal to the population mean of the sleeping hours of the second years. So we can test that hypothesis for this. And then, still using t-test, we may compare the sleeping hours of the second years versus the third years. And again, we have a null hypothesis comparing or expressing equality between the population means of the sleeping hours of these 2-year levels. And lastly, to complete our t-test, we may also compare the mean sleeping hours of first years to that of the third years with the null hypothesis expressing equality in their population means. So you see, what we've done here is to use t-test to compare two populations per t-test. And since we have three populations to compare, we had three combinations of comparisons. First years versus second years versus third years, and now first years versus third years. So we have arrived at these three null hypotheses. And of course, we're going to pair them with their alternative hypotheses, which we're not going to show here anymore. But if you can remember, every time we do a hypothesis testing, like the t-test that we have here, we always set our significance level or alpha. And let's just say we will be setting our alpha for each of these at 5%. Okay? So, take note, when we did our first t-test, that's this one, that's 5% alpha. And then when we made our second t-test, this one, that's also 5% alpha. And our third test is also 5% alpha. And then we are going to come up with a decision, an overall decision as to whether the means of these three populations are indeed equal to each other or different. So that's our main goal. So now, because each of these tests, each of the three here are independent tests, okay? And then we are going to come up with a final decision using the three tests. Then, in order to compute for the total confidence, we need to get the product of the confidence intervals for each of these three. So, we're going to have 0.95 times 0.95 times 0.95. Therefore, using these three tests, three t-tests, the overall confidence is not 95%. Instead, it's now 85.74%, which means to say that your alpha, even if each one is 0.05, the alpha now, the total alpha is now going to be 100% minus 85.74%, or 0.1426 or 14.26%. And that's a very large value for alpha. In fact, that's synonymous to saying that the test result is not significant. So there is a problem with using t-tests if you want to compare three populations, because you're going to end up with three t-tests as what's shown here, and each one has its own alpha and confidence level. And in order to get the total alpha and confidence levels, we need to multiply them using the multiplication rule of probability. So this is no good at all, okay? This is not acceptable. So the question is there a way to compare three populations, or the means of three populations? And the answer is yes. And obviously, it's not through the use of t-tests. So in this particular module, we are going to focus on comparing three or more populations using what we call as multi-sample inference. Okay? So this is when we compare more than two distributions or populations. And the process that we are going to do here, okay, is called the analysis of variance, or ANOVA. And this is what we are going to be talking about for the next two videos for this particular module.